I am going to flip this coin 3 times. And I want you to consider what could happen if I flip this coin 3 times. Um, Specifically, I want you to consider how many times could this coin land on heads. One thing that could happen is it could not land on heads at all, in which case the number of heads would be 0. It could land on heads 1 time and tails the other 2 times, in which case the number of heads would be 1. Or, of course, I could get 2 heads or 3 heads. So if I let x equal the number of times that the coin lands on heads, then x could equal 0 if I don't get any heads at all. Could get 1 head, 2 heads, or 3 heads. Okay. Now, let's look at the 0 case first. For this to happen, the sequence of events has to go like this. I would flip it, I get a tails. Flip it again, get a tails. Flip it again, a tails. And in fact, I think that's the only way that I can get 0 for my number of heads. Okay, so there's one way that can happen. Okay. Now let's consider the case where I get 1 head. Now here, okay, I could get the head straight away, followed by 2 tails. Or I could get a tails, then get the head, and then the tails. Or I could get 2 tails, followed by heads. If either one of these 3 sequences of events occur, then the number of heads that I get is 1. How about 2? Well, for 2, I'll erase this sequence. I think I'll put it over here. All right, to get 2 heads, I could get 2 heads right in a row, then a tails, or I could go heads, tails, heads, or I could go tails and then heads, heads. So I think there's 3 ways that I can end up with 2 heads. So 3 ways that x can be 2. And then finally 3, I think there's only one way you can get 3 heads, and that's you got to go heads, heads, heads. Okay. Now let's consider that the probability of heads, heads, heads. To figure the probability of that sequence of events happening, it's this and this and this has to happen. These are independent events. I can multiply the probabilities. 1/2 times 1/2 times 1/2 gives me 1/8. So the probability of getting of x, the number of heads being 3, is 1/8. So if I flip a coin 3 times, probability that I get all heads is 1/8. Now, same way with 0. Probability of getting tails, tails, tails is also 1/2 times 1/2 times 1/2, which is 1/8. Now the 1 is a little bit more interesting, and so is the 3. All right, the 3 is still up here. These 3 sequences of events lead to, or sorry, that's the 2, excuse me. These 3 sequences of events lead to an x value of 2, where you get 2 heads. The probability of getting heads, then tails, so the probability of heads is 1/2. That's 1/2. That's 1/2. So that's 1/2 times 1/2 times 1/2. 1/8. Probability of this sequence occurring is 1/8. The probability of this sequence occurring, you can probably tell, is also 1/8. Same with this last sequence. Now the thing about this is these 3 sequences are disjoint. They can't. 2 of them can't happen in the course of the same experiment. So if this or this or this happens, I end up with x equals 2. And for an OR probability with disjoint events, we add the probabilities. So 1/8 plus 1/8 plus 1/8 gives me 3/8. Now, it's not too much of a stretch to realize then that the probability of getting 1 heads using the same logic is also 3/8. Now, what this is a probability distribution for the random variable x, where x is defined as the number of heads that you get during this chance experiment. So this is one form that a probability distribution can take on. Okay, you've got the possible values of x and then the probabilities of those values occurring. And once I have this probability distribution, I can answer something like, questions like this. What's the probability of getting 2 heads or more in this chance experiment? Well, the probability of getting 2 or more heads would be the probability of getting either 2 or 3, and they're disjoint. I can add them. The probability would be 3/8 plus 1/8, which is 1/2.